Okay, so let's get started. We're going to be taking a look in this training module at working with our engine diagnostic programming for our Gen 3 Coyote engines. So we're going to jump in, we're going to open up a stock equivalent calibration file for this tutorial. We're going to go through our diagnostic area, just talk about a few key things that we need to update and change depending if we're naturally aspirated or forced induction. We're also going to be taking a look at how to deal with DTC or check engine lights within our diagnostic area as well. Let's jump in, let's open up our stock file, and let's start our tutorial. We're going to go up here to File, we're going to go to Open, and we're going to open up any stock file found in our sample calibration file subfolder. You can even open up your file from your vehicle if you have that available. I'm going to go ahead and open up 2020 Mustang GT manual stock here for this training module. I'm going to go up to the Engine Diag tab, and in here we have couple different sub-tabs. We have a general, airflow, misfire, exhaust, and DTCs. Each of these are going to hold the different portions or different areas that we could potentially edit and change in our calibration file. They're going to be related to things like our check engine light or DTCs. So if we want to go ahead and avoid triggering a certain DTC, we're going to talk about our throttle correlation here. This is going to be a prime example. To keep our throttle fail-safe protection in place, we want to be able to calibrate these tables if we're forced induction. So in order to avoid throwing a P0068 DTC code for the engine control module, we need to go in here and update some things. But you'll find there's other areas here that we can go in and change so that we avoid throwing certain check engine lights that are a little bit more common on our Gen 3 Coyote engines once we start to do some heavy modifications. So let's jump in here to General, and we're going to move across in the tabs and talk about what things we may want to change. And we'll finally end up the video taking a look here at our DTCs list and just learning how we can turn off common DTCs that'll get thrown on a race vehicle if you're installing the typical aftermarket parts. Let's jump in here to our General section and start. So taking a look, we see we have our oil area here. This relates to the oil pressure sensor. This is the min and max that we have for the sensor, the min and max range. If you're not changing your oil pressure sensor out, you'll leave that alone. And typically we don't, so we don't need to edit that. There's a variable cam timing test. This is the minimum ECT that it's going to run at. There's 50 degrees Fahrenheit. If you're deleting your VCT, so you're deleting your variable cam function on the engine, you would want to go in here and set the minimum at something really high, such as 300 degrees, so you never go into the VCT test, the cam test, the internal test in the engine control module. A couple other things we have here, temperature sensors. Now, we typically don't edit anything in here unless for some reason you're going and changing out your air temp sensor to a different sensor, or you're turning on your secondary air temp sensor. Find Roush calibration files for Mustangs have 2 temp sensors, and they are turned on and they're all populated with those values. With a standard GT file, we do not really change anything in here. In fact, probably just leave everything alone. There's really no reason to update or change anything. Taking a look, there's also a fuel injector max flow DTC that we can change. So P0087/88 test. This is going to be a normalized injector flow. You could change this value if you're running into problems triggering your max flow through the injectors. You could raise this up to 0.95 or 1.0. That's going to be for a highly modified, higher power Mustang application or F-150 application. We typically don't change this, so we'll just leave that alone. Under airflow here, there are some things that we do want to potentially change. If we take a look here, if we specifically look under our mass airflow sensor section, we have our high fail AD counts. This is set to 980 currently. There's a low fail AD counts. This is set to 50. Now, the way the AD counts are going to work, it's analog to digital counts, and this is used in the internal logic of the engine control module. It's going to be between a 0 to 1024 scale. If we're taking a look at our mass airflow transfer curve, we know that's based on period versus airflow. If we're taking a look at the very lowest value that can come out of that mass airflow sensor, the period value, that would be the equivalent of a 080 count. And if we're taking a look at the peak of the mass airflow transfer function curve, which I believe is something like 75 or 30, we could jump back in here and take a look, whatever that's going to be, the peak value, that's going to be correlated to the position of 1024 in the internal AD counts. What this is saying is if we start to hit 980, of the 1024 scale, so 0 to 1024, we're at 980. So it's translating the math period value to an internal lookup of equivalent of 980. It'll throw an internal checksum and throw an error for the mass airflow sensor, essentially fail the math. We want to raise this up. We want to keep some failsafe in place. If you're force induction and you're getting towards the top portion of your math scale and you're essentially maxing it out, you want to go in here and raise this value up so you get all of that potential math flow registered from the engine control module without going into a potential failsafe limp mode. So we want to raise this to 1023. The maximum is 1024. That just keeps a slight bit overstep for it to go into a failsafe protection mode. Everything else here we can keep where it's at. I would recommend, if you are raising up your rev limiter, you could raise up your failed RPM here as well. So this is saying above this RPM, the math isn't going to fail. We usually want the failsafe protection to match our rev limiter. So thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.